Good morning, everyone. I'm going to be demonstrating how to set up the BotBlox DroneNet adapter. So that's this little adapter here. I've got one of them in my hand here, there, and you can see the photo of it with all the pinouts. Now, what this adapter allows you to do is bridge between high-speed serial on a UART and Ethernet, and also bridge between CAN and Ethernet. So you can combine this little board with a flight controller that doesn't support Ethernet to add networking to the board. So if, for example, you've got something like this, which is a cube orange, and that doesn't have an Ethernet port, then you can use this little adapter to be able to provide Ethernet capabilities to this board. Now, there's actually two boards available that can do this. One is the BotBlox board, that's this one. There's another one that ArduPilot is bringing out, which looks like this little one. They don't have a product page for it yet, but it will be coming out very soon. This particular one just has a single RJ45 on it, so it doesn't incorporate a network switch. Whereas the BotBlox one includes a full 5-port network switch, which means you can connect more than 2 devices at the same time. So you can have your camera with its video on Ethernet, as well as your IP radio, and have your flight controller and all of your various CAN devices all interconnected. Okay, so what I'm going to do is demonstrate how to set up this device from scratch. So what I've got here is a copy of Mission Planner, and I've connected to a Cube Orange Plus. Now, I'll just show you, before we jump into that, I'll show you how to make sure you got the right firmware. If you're running a Cube Orange Plus with the latest firmware, that already has support for this type of networking. If not, say for example, you've got a Cube Orange, then what you can do is go to the ArduPilot custom build server. So that's custom.ardupilot.org. And on this page, you would select add a build, and then you can select the latest stable ArduPilot build, which is 4.5.6 as of this week. And then what we can do is select the board that you've got. So I'm going to select the Cube Orange, and then what I'm going to do is go and enable PPP networking. That's this option in the middle here. And at the same time, I'm going to disable a couple of features that I don't need. So let's imagine we don't need precision landing, and we don't need, what's another one? Say the proximity sensors. That will save a little bit of flash space, which will allow you to fit the feature of PPP networking, which is what you need. So what we need to do now is click the little Generate Build button, and that will start a build for your board. Now, this applies not just to Cube Orange, it applies to any H7 based flight controller which doesn't already have native Ethernet. If you've got native Ethernet on your controller, if for example you've got to say a Pixhawk 6X or similar, then you don't need to use these adapters. All right, so that is going to start a build and build Cube Orange with the networking PPP support. And I'll just put that away, and I've actually built one of them earlier. And so you'll end up, when the build finishes, with a little build folder like this. And there you've got your ArduCopter.apj, which is what you would load on the board. Okay, so let's go back to setting up this adapter. And I've got a little photo here of how it all goes together. So this is a Cube Orange Plus, and I have connected the BotBlox DroneNet here. And I've connected it, in this case, over the high-speed serial on TLM2 and also on the CAN port. And the reason I need to connect the CAN port is for configuring the device. We configure it over CAN, though once it's fully configured, it can operate without the CAN. Although if you want the CAN bridging feature, where you can bridge your CAN onto your network, then you will need the CAN port plugged in. And so just the ports that we're using here, so we're using one of these Ethernet ports. They're available with different pinouts. There's a 5-pin Ethernet port, which is suitable for QPilot devices such as HereLink, and there's 4-pin Ethernet ports, which is the more common Ethernet port used on a number of devices. Then we're also connecting this UART port. I'm connecting that onto TLEM2 on the Cube Orange, and you've got various powering options. You can power the device from this power port here, or in fact, you can power it. If you plug in the CAN port, then it'll just power over the CAN device. Okay, so let's go. We've got it plugged in, and I'm now going to show you how to set it up. So for this demonstration, what I've done is I've completely wiped the parameters on this Cube Orange Plus. So we're starting from scratch, and I've connected to it over USB, and we're going to show how to set it up from scratch. Because we're going to be configuring the device over CAN, the first thing I need to do is go and configure CAN. So I'm going to enable CAN on the first device there and write that parameter. And then I also need to go and configure networking. So search for net underscore, and I've got to turn on networking, and that will enable the Cube Orange Plus to interact with Ethernet networks via this PPP adapter. So I'm going to turn that on and write that parameter. All right, great. And other options that I'll need to do, I'll need to set serial 2. So I'll need to set the serial 2 protocol to PPP because that's going to be what links the Cube Orange to the DroneNet adapter from BotBlox. I'm going to set the baud rate to 12.5 million, and that's actually not an option there. I'm going to have to type in a value, and 12,500. So 12.5 megabaud. That's the highest possible baud rate that we can do on a serial port on a something like a Cube Orange or any H7 based flight controller. So we've now set that. So we've now got networking enabled, we've got CAN enabled, and what I'm going to do now is tell it to reboot the flight controller. So I've got this pre-flight reboot shutdown selected, and I'm now rebooting it. That will now reboot. All right, great. So come back in here and I'll refresh my parameters, and let's have a look at the network options we've got. And so we can put in various options here to control things like IP addresses, etc. But let's jump straight into the configuration of the BotBlox network adapter itself. Now, that device should have now shown up under DroneCAN. So what I'm going to do is start up Mavlink CAN 1 to connect to the CAN bus. And what we see now is a number of devices. I've got a Maytech rangefinder on my CAN bus, and down here we can see the BotBlox DroneNet device. So what I'm going to do is go to the parameters. So we're now talking over CAN to this Ethernet bridge device, and we can use that to configure it. All right, now by default, the BotBlox DroneNet device uses DHCP to get an IP address. And what I'm going to do for my use case is I'm going to turn off DHCP, and I'm going to set a particular IP address that I want on my home network. So my home network is 192.168.2.99, and I'm also going to set, that's actually the gateway address I've just set there, so I'll set the gateway as 15, and then the IP address I'm going to set to 2.99. You can choose any IP address you like, just pick one that's on your network. 192.168.144 is a common one if you're using cameras like a CE camera. All right, so they're the main parameters that I need to set. So I'm going to write those parameters, and what I'm going to do now is tell the BotBlox DroneNet adapter to restart. All right, so it's going to reboot. And there it is, now been up for 3 seconds. In maintenance, it'll come up in the normal mode, initialization. Great, it's now operational. Okay, so now it's up, now we've configured that to a particular IP address. What we can do is we can go and now talk to it on that IP address. So I can type in the address of my DroneNet adapter, and it should now be coming up on that address. Let me just see if I can ping it, 102.168.2.99. There it is, yes, and it has now come up on the web interface. All right, so what we're doing now is we're now talking over the network to the DroneNet adapter. So this is running the latest ArduPilot firmware, and so it shows that it is coming up on the network. This interface is principally, the main purpose of this interface really is to allow us to update the firmware. So we could, if we wanted to, go and update the firmware on this device. And so we can go into the little firmware update and select there's the ArduPilot Drone CAN firmware, and I'll upload. What that'll do is update the firmware on the DroneNet device. So you can do that over the network using the little web server. So that's done, and so this will now come up with the new version of the firmware. Takes a few seconds for it to start up, but it should in a few seconds start up there and show itself up on the network. All right, I'll just make sure it's still got its parameters there. So I'll just connect in here, and IP address 2.99, there it is. It's now come up on the network. It can take a few seconds for it to start up. All right, so we can reconnect there with the web interface, and it's back there now running with the new version of the firmware. Okay, so what can we do with this? Well, the next step is on our CubeOrange Plus, we can in fact set up a web server on this CubeOrange Plus. And that's useful because it can allow us from our ground station over a radio link to access, for example, the file system on the CubeOrange Plus. And so what I'm going to do is show you how to do that. So I'll go into the config. The web server is a Lua script, and I've got to go and turn on Lua scripting. So I'll turn on Lua scripting like that. Right, and it's now refetching those parameters, and I'm going to go into the MAV FTP, and on the MAV FTP, I'm going to have a look in the APM scripts folder, and I've previously uploaded the little net web server.lua. So that net web server is an applet on the ArduPilot website. So if you want to go and get that, you could go GitHub and then have a look in ArduPilot, the ArduPilot firmware, and we can pop into libraries, AP scripting, and then applets, and there is a little net web server down here, netwebserver.lua, and there's also a README that explains how to use it. So this is the little web server application documentation, and this is the script itself. So this is the file that I downloaded, and I put it on the web server here. All right, so we've enabled scripting, and so what I'm going to do is once again reboot the flight controller so it takes starts up the Lua scripts. All right, great. And so that started up Lua scripts. Now I've got to go and configure the Lua script. So I'm going to go to the full parameter list and just refresh those parameters, make sure it's got them. And then I'm going to look for the web parameters. and it's enabled the web server, and I'm going to make it bind on port 80, which is the standard port that a web server uses. It defaults to 8080, which is useful for debugging. And I'm also going to go into my scripting, and I'm going to increase the amount of heap available. It's actually already got quite enough heap size there, I think, to run the web server. So I'm going to write those parameters, and then I am going to restart scripting. So scripting, stop and restart. Great. And we now see that it says starting web server starting on port 80. So we are now running a web server directly on the flight controller. All right. So now this should have started up the PPP gateway. Now you'll notice there's this little message here, net IP, and I'll just make this window a little bit bigger so it might be easier to see. So when the cube orange started up, the way it works is that we have this high-speed UART connected between serial 2, telemetry 2 on the Cube Orange Plus and this UART port here, and that's set at 12.5 megabit, and the protocol is set to PPP. Now the Cube Orange Plus then gets given an IP address by the DroneNet device, and we can see that in the startup here, that the Cube Orange has been assigned, and the default is that it's assigned an IP address one more than what we set for the DroneNet. So if you remember, we set the DroneNet device to 192.168.2.99. And so now I should be able to get to the Cube Orange Plus. Indeed I can. So I'm now pinging the Cube Orange Plus over the network, and the packets are actually transiting via this little DroneNet board, right? So they're going in over the Ethernet port, and then they're going across the UART PPP link into the Cube Orange Plus. So we now have networking on the Cube Orange Plus. So what I'm going to do now is connect into the Cube Orange Plus. So we are now on the web server running on the flight controller itself. And so this web interface, again, it's fairly basic. It just shows, if we had a GPS lock, it would show our location and that sort of thing. It's a very, very basic interface. You might like to customize the web interface. It's just there's some HTML you can set up to customize this and add more information if you want to. But one of the most useful features is this button, SD card access. So I can now go into, for example, my logs directory, and there is a flight log that I've got on this one. So I can now click on that and tell it that I want to keep that log, and it's now going to download a flight log. So there's my flight log downloaded to, I don't need that, go away, and I don't want that, and I don't want that. All right. So I'm now able to download log files across the network from a web server running on the Cube Orange Plus. Now that's terribly useful. First of all, it downloads faster than it would over a direct USB link. Ethernet with the 12.5 megabit link is actually faster than USB. But the second thing is that it means you can access your log files from your ground station remotely. So if you've got an IP radio link, something like a HERE link or similar, and you can then use a web browser and connect into your flight controller and access your log files across the network like this. All right, so I'll show you one more feature here. This is DroneCAN GUI tool running on Linux here. I'll just start it again and show you the way I'm connecting to it. So when I start DroneCAN GUI tool, one of the newest features we've got on this little adapter is support for multicast UDP. And that's bridging of CAN bus data onto Ethernet, which allows us to do drone CAN over Ethernet. So I'm going to connect to the multicast network, which is a mirror of the first CAN bus on the DroneNet, the BotBlox DroneNet device. When I connect to that, then I can actually see all of the CAN bus devices that I've got on the network. This is coming across the Ethernet link, and I'm seeing the CAN bus devices on Ethernet. So it gives you a bidirectional bridge between CAN bus and a Ethernet network. This means, for example, that a companion computer that is on Ethernet in your vehicle can access the CAN bus and log or control any of the CAN bus devices on your flight controller over this multicast UDP CAN Ethernet link. So I can, for example, here go and have a look at the properties of this Maytech rangefinder and access it via the Ethernet link. I could update its firmware. I may well have yes, there's a firmware there. So I'm now updating the firmware on this Maytech device across the Ethernet from my ground station across a radio link if you want to. And so it'll now update that firmware. I'm not sure quite how big that firmware is, how long it'll take. That is 280 kilobytes, so it is going to take a little bit of time. This column here in the DroneCAN GUI tool shows the number of kilobytes that it's sent so far, and so it's getting there. And we can also update the firmware on the BotBlox DroneNet device itself. So I'll just wait for that update of the Maytech board to finish. Nearly there. All right, so that actually got stuck at the last part. That is annoying. Well, okay, I'll just show you all the parameters on the DroneNet board, and what I'm going to do is I'll tell this one, well, as we'll try and debug it, I'll tell it to restart there, and then I will, so it's restarted, and it's still in maintenance mode, so it still needs a firmware update, and I'll try that firmware update again. It's possible that I've got a bad firmware. Oh, that's why. I'm uploading a Maytech G74, wrong firmware. All right, let me show you how to do that properly. APPerif. So if I go to firmware.ardupilot.org and APPerif, if I actually upload the correct firmware for the device, it's got a much better chance. And this is a Maytech H743, Maytech L431 rangefinder. There it is. So I'll now download that firmware. Great. And now if I upload the correct firmware for this device, then instead of this Maytech G747 firmware, which is the wrong device, so I'll stop that and I'll just tell it to restart, and then I'm going to update the correct firmware this time. APPerif checks, it won't boot unless it's got the right firmware, so that's why it was failing. And so if I now go to this correct firmware for this device, then that should work fine. APPerif, so that's 130 kilobytes. So it's going to come up a little bit faster than the other one. There's always something you show wrong when you're giving a demo. Uploading the wrong firmware is certainly an easy mistake. There it is, initializing operational. Okay, so we now have our Maytech L431 rangefinder working. All right, so we've also got our BotBlox DroneNet showing up, and we can actually update the firmware on this BotBlox DroneNet device over the Ethernet link we've got with Multicast CAN. So I'll go update firmware, and I'll go to this one here, which is one of the BotBlox DroneNet firmware that I've built. And so it's now going to go into the bootloader because the new bootloader for the BotBlox DroneNet supports multicast UDP as well. So what we're now doing is updating the firmware over the network using CAN and you'll notice it actually updates quite fast. There it is, it's booting, Great, we've now updated the firmware on that device. So that's the equivalent of what I did previously, where I demonstrated connecting to it here, this PPP gateway, and updating firmware via this method. Doing it over this, using this method, is exactly equivalent. All right, I hope that gets you all started with using the BotBlox DroneNet device. I'm excited that Ethernet is going to be available to people with flight controllers that don't have Ethernet ports. Please remember also that there's the QPilot device, this little one. If you just need a single port, if you already have a network switch in your aircraft, then you don't need the BotBlox DroneNet because it has the switch, and if you've got a switch, you could just use this a smaller device, and it's got all the same capabilities, it just doesn't come with the switch. So enjoy, and hope that the networking works well from you, and you're able to take advantage of these new capabilities in ArduPilot.